Hello there everybody. Today I'll be showing you some truth tables. Now truth tables is a subset of the topic of logic theory, which is part of statistics. Truth tables, it's a very simple concept, but it gets more and more complicated. I'm just going to be showing you the basic truth table in this video. So a truth table pretty much tells us what is true and what is false. So let's say we have two events. Let's call them P and Q. Now, let's say there are options. It's either true or false. So we have to list every single possible option. So P could be true and Q can be true. P can be true, but Q can be false. P can be false and Q can be true. And lastly, they can both be false. So this is every possible option. We can either have two trues, one false, one true, and the opposite of that. And then we can also have two false. So that's very simple. But then we can make it more exciting. Now in logic theory, we have this notation. It's like an arrow pointing upwards. This means and. So for the next part of the diagram, we're going to have P and Q. So P, I'm trying to do this in black. P, arrow upwards, Q. Now what this means is that are P and Q true? Well, for the first one we look, they're both true. So yes, the top P and Q are true. So that's true. Second one, we see true and false. Are they both true? No, because one of them's false. So we put a false here. The third one is false, one is true. So are they both true? No, false. Both of them are false for the last one. Are they both true? No, they're both false. Next, we have P and or Q. So if you've done set theory, and is the intersection, and we also have or. It's very similar to like A and B and A or B, and that in set theory you use a more curved notation, but in truth tables we use a more hardcore straight lines, as I think this is used for computer programming, and it's easier to type in an arrow upwards and arrow down rather than the curves. Okay, so P and or Q. Well, let's look again at our starting two. P is true, Q is true for the first column. So either one of them is true, which is true. So we put true there. The second one, one's true, one's false, but there is a truth within them, and we're asking, is either of them true? Which is true, one of them is true. The third one of them is true because the second one is true, but the fourth one, they're both false, and or none of them are true. So we put a false here. This is very simple. Truth tables is a very nice topic, but this is where things start to get a bit more tricky. So if we have this squiggly line, that means not. So if we have squiggly line followed by P, that means not P. Squiggly line followed by Q, not Q. And what not means is just it's the opposite. So if we continue our truth table, and we now have not P, we look at our truth table. Okay, so P is true for the first column. That means it's false because it's the opposite. And the next one is true, it becomes false because it's the opposite. The next one is false, that becomes true. The last one is false, that becomes true. Okay, next column, Q, not Q. First starts off with true. The not true is false. Then we have a false. Not false is true. Then we have a truth. Not true is false. The last one is false. Not false is true. So there we have it. That's truth tables. I hope you enjoyed this video. Thank you for watching and goodbye.